students. In this video we will see some examples of how to draw a DFA. Okay, so first problem, DFA to accept the strings of A's and B's having exactly one A. Okay, so previously video we have discussed exactly one A, but here the strings are A's and B's. So as they are given DFA, so what is DFA? For every state it has to take the transition for every input. That is the main basic definition of the DFA. So firstly, you have to write the basic of it. What is the question? Exactly one A it has to accept. So Q0 to Q1, minimum 1A transaction it has to take from the starting state to the final state. Okay, and left out it may contain any occurrence of B. Here problem arises is that your Q1 is taking the transaction for B. Okay, it should contain exactly 1A, not at least 1A. It is exactly 1A, means only 1A should be present in the designed machine. Right. So in that case, Q1 also has to take the transaction. For that, we have to create a one more state here. See, here from Q1, we have to take one more transaction as A to the Q2 state, and Q2 state also has to take the transaction for both the inputs in input A and B. Okay, so here all the states like Q0, Q1 to Q2 both are taking transaction for both the input symbol, then only it is said to be a DFA. So here one more thing, after the transaction from Q1 to Q2 there is no transaction back to the Q1, right? So we are saying it is a trap state. We'll say the string is accepted only when it is starting from the start date and end at the accepting state. If it is going back to the Q2, if it is reaching to the Q2, there is no way back to the Q1 again. So we say this as a trap state. There is no way back to the accepting state. So this is trap state. So here what are the strings accepted? If you see means exactly one A, so it may contain any occurrence of A plus any occurrence of B. So it may be minimum A or BAB or BBB, so on, with the any occurrence of B's followed front and back of a A. So this is the strings accepted by this machine. Next problem. Obtain a DFA to accept a string of A's and B's having a substring AAB. Okay, so having a substring AAB means minimum AAB should be there continuously, and it may contain any other string front or back of it. Okay, it AAB should be present in the completely accepted string from the generated machine. So firstly, AAB you have to make a state, starting state and the ending state for single input, single transaction. From each state you have to design. Nextly, you have to give the one by one transaction for every state. Since the input is A and B, every state has to take the transaction for both the inputs A and B. Then only it is said to be DFA. So here first Q0 is taking transaction to Q1 with the input symbol A. So input symbol B we have to give. So we are giving it as a loop, because if it may be any times if it occurs also, there will be a string AAB accepted by the machine, substring, right? The same way Q1 is taking transaction for the input symbol A. So Q1 is not taking for B input symbol. So for that it is giving to Q0. Okay, so A, again B, again AAB. So like that, when it has to reach to the final state, it has to go through AAB. Like that you have to design the diagram. Similarly here, Q2 is taking transaction for Q3. So here any occurrence of A, it is given to Q2 itself, because our substring is AAB. So if it takes one more A, doesn't matter. So AA it may repeats any number of time followed by B, right? So like this you have to design a diagram based on the question. Similarly here at last Q3 also has to take the transaction, so AB any occurrence. So this diagram at last from the starting state to final state, minimum AAB at least once it has to read. This is our transition diagram. Here it may contain any occurrence of A, B in this loop, but minimum one occurrence. Substring means one occurrence should be there. Now how to write a transition table for this one? So this is a transition symbol, input symbol A and B. These are the states which are there in our diagram. Then starting state is represented by an arrow, that is Q0, and final state is a Q3 represented by a double circle in the diagram, whereas in table it is represented by a star. Now Q0 for A. Q0 for A, it is taking transition from Q0 to Q1. So you have to write Q1 here. Again Q0 for B, it is taking transition to itself. So Q0 you have to write in the table. Same way Q1 for A, it is reaching to Q2, and Q1 for B, it is reaching to Q0. So Q2, Q0. Again from Q2 itself it is taking, so Q2, and for B it is reaching to Q3. So Q0, Q3. Similarly Q3 itself it is taking, so Q3, Q3. So after that you have to write the definition. Q, what are the number of states present in the diagram? Q0, Q1, Q2, Q3. Input symbols are A and B only, and starting state is Q0, and final state is Q3, and transaction which is shown in the table. So this is how you have to write the complete problem.